And the letter doesn't really matter. Sometimes if it's a story problem, maybe that letter represents what we're talking about, trying to maximize or minimize the function here. Sometimes it'll be f, it could be p, it could be any variable, but the variable really doesn't matter. But this is what we call our max min function. It allows us to figure out what maximizes or minimizes the function, okay? We don't do that, we don't do anything with this until the very end. It's the first thing that's listed, but we leave it for the very last thing. And so we'll come back to that here in just a second, or in just a little bit. We also have several inequalities given to us. All right, the first thing that I'm going to do here, for these today, I would say, you can use graph paper, but we're going to be typically limited, not always, but typically limited to the first quadrant. And that's what these two inequalities are telling us. We are limited to only the first quadrant here, because x is greater than or equal to 0. That is a vertical line shaded to the right. Y greater than or equal to 0 would be a horizontal line shaded above, okay? So it's basically to the right of the y-axis, above the x-axis, so that we're now in the first quadrant, basically. This whole area with these two inequalities would be shaded. But now these two are going to limit our, our bounded region, and I'll talk about what that means here in just a second. Okay, but that's why I'm only drawing the first quadrant up here, is because x and y both greater than or equal to 0 limits us to that quadrant. Both of these are in standard form, and so you can do whatever you want to get some points to graph this. If you want to solve it for y, you can, especially if you want to be able to graph it and put it into your calculator. We also talked about when it's in standard form, that putting it and doing the cover-up method is also a good method. And for this one, that's probably where I'm going to go to, and I'll kind of show you why. You're going to get some decimals here, and so that's why some people may not think of it as being the ideal method, but you're going to get decimals or fractions if you do the slope-intercept form also. And the only reason the slope-intercept form might help us is then we could use our calculator. But I'll show you a different way that we can get what we need rather than just graphing it using slope-intercept form. So for this one here, we're going to do the cover-up method. We're going to plug 0 in for x, which is 5 times 0. We call it the cover-up method because we cover it up. So I have 3y equals 34. And so that would be 34 over 3. And so that's like 11.3 repeating. Then we do the same thing for the x. If I plug 0 in for y, I'm going to cover up 3y. I have 5x equals 34. 34 divided by 5 would be like 6.8. And here the decimal probably would be a little bit better because it kind of tells us a little bit where we're going to end up on our x and y axis. I'm not going to label the x and y axis yet. I'm going to wait and do my other cover-up method to see how far out we're going to have to go. I'm going to do the same thing for the second one. That's why I'm kind of doing these in two different colors so we can see the difference between these two. Same method though. We're going to plug 0 in for x. 3 times 0 is 0, so we're covering that guy up. 5y equals 30. 30 divided by 5 would be 6. And then I plug 0 in for y, cover it up. I have 3x equals 30, so x would be 10. So your x values have to go out to at least 10, because you have 10 and you have 6.8. So we're going to go out to 10. That's as far as we need to go. My y values, I have 6 and I have 11.3. So we need to go up to, I would say probably 12. So that way 11.3 is included in that. And that would be 12 right there. Okay, and we're just going to kind of eyeball about where our points would be here. 6.8 would be about right here. And I'm just going to go ahead and label that as 6.8 right there. 11.3 would be right there. And we're going to connect those together and make a line. I'm not going to continue it on forever because we already talked about how we're limited to the first and second, or just the first quadrant. For the second graph, 10, 0 is on the x-axis, 0, 6 is up 6. We're going to connect those. Okay. Now, both of these were less than or equal to, and we didn't ever switch our sign or anything. So the shaded region that we're looking at here would be below both of those lines, but above and to the right of the x and y axis. So it would be that little bounded in region right there. Okay, and that's kind of where we stopped on Friday with the first part of 6, 7 is being able to look at this and just graph it, right? But now we're going to take it a step further because now we want to try to find out what maximizes or minimizes this. And so what we're going to do is we're going to take that bounded in region, and we have 4 points that basically enclose it. It's kind of a quadrilateral. Not kind of, it is a quadrilateral. Just not a normal looking quadrilateral, right? If I connected those 4 points together, it would give me a 4-sided figure. So we have 4 points that we're going to use to try to determine what minimizes or maximizes this function. So we're going to take it one step further. And this is the part that we didn't do on Friday, is we're going to take that function from the very beginning that we haven't used yet. And we know that one's different because it doesn't have an inequality in it. It's just a regular old equation, okay? And we're going to plug in the 4 ordered pairs that bound this region in, okay, and closes it. 3 of them are pretty easy to find. We got 0, 0 down here. That's pretty easy, okay? We got 0, 6, which is at the top point of the graph here. We got 6.80, which is on the right-hand side of that. And then we got to find this guy. Okay. And there's a couple different ways that you can do that. If you graphed it, if you solved for y and put it in slope-intercept form, you could just find the intersection of it, okay? But because we didn't solve for y here, then we got to find a different way of solving for that. This point is the intersection of these 2 equations, right? And so what I could do here is I could put them in a matrix together, okay? This is the top or the first equation. This is the bottom equation. If you had to, you could graph it. You could do substitution. You could do elimination. You could do any of those methods that we've done throughout the chapter. But the best, quickest, easiest way of solving is just do the matrix, okay? And so we're going to put it in as a 2 by 3. and we're going to find out where these two cross. Okay, so let's put this into our matrix real quick, and let's find out where do those two equations cross at. Try not to eyeball it, okay? You could probably guess about where this crosses, but because our graph is not very accurate, I didn't use a piece of graph paper here. We may not be perfect here. So don't just try to look at it and determine what that order pair is. Plus, sometimes my answer here might be a decimal or a fraction, and so that wouldn't be a very good guess if I did that. And just remember, you got to do the RREF to get there. So what we should get, 5.3. Does that look right? Got way too much stuff. Okay, so that would be the intersection point. And you might say, well, it doesn't look like they cross the 5.3, and that's why you don't necessarily want to go off the looks. Looks pretty close though, right? Looks fairly close, estimated wise. If I did it on graph paper, it probably would look a little bit better. But you don't necessarily have to pay attention to that part, okay? Once I have those 4 points, then we're going to take these 4 order pairs, and we're going to plug it into this function right here. And so 5 times 0 plus 36 times 0. That's pretty easy. That is 0, okay? Not much work that needs to be done there. We're just evaluating what the value would be. Okay, here we got 5 times 0 plus 36 times 6. And that would give me 216. Then we got 5 times 6.8 plus 36 times 0, which is just 5 times 6.8. That would give us 34. And then the last one, we're going to do 5 times 5 plus 36 times 3. And that gives me 133. Okay, so the question is asking us what maximizes and minimizes this function. So we're going to look at these values and figure out which one is the maximum value. This point right here is what we call the max. The minimum is obviously 0, because that's the lowest value that I get. And that would be what we're looking for our solution. Okay, so it just takes it a little bit further than what we did on Friday. Okay, I'm going to do another one here. This one's just a little bit different. This is number 61. Okay, they start off by giving us this function. Okay, and that is the one that we are not going to graph. We're going to leave that alone to start off with. We have 6x plus 8y is less than or equal to 48. Okay, and then we got a couple of different functions here. So I'm just trying to give you a general idea of some different types of inequalities that you might be given. The first one we have here is kind of like the ones we did just a second ago. These two are a little bit different. Here, we're saying that the y value has to be between 0 and 4. So y value is your y-axis, right? Once again, we are limited to the first quadrant because x and y both have to be bigger than 0. So we're still in the first quadrant. It's a little bit different way of expressing that, but we're still only working in that upper right-hand corner. Okay, my y value has to go up to 4. My x value is going to go over to 7. So right now, we're working in this little box down here, okay? Little rectangle, basically. But we got to add in the third inequality that we have here and see where all of those are going to intersect and see where the bounded region is going to be. Once again, when it's in standard form, I like to use cover-up method, okay? Do you have to use the cover-up method? No. You can simply solve it for y, especially if you want to use your calculator. I just think there's more steps in that and maybe a little bit more errors that you could make. And so I like doing the cover-up method because it's pretty quick and easy. All we have to do is plug in 0 for x, cover it up. 48 divided by 8 is 6. We can get to an ordered pair pretty quickly. And then I plug in 0 for y, cover up the 8y. 48 divided by 6 would be 8. So we're at 0, 6. And we're at 8, 0. We're going to connect those together. My shaded region here, and once again, it's less than or equal to the blue line, so it's going to be underneath the blue line. So my shaded region would be everything inside that rectangle, but under the blue line. Okay, and that's the area that we're looking for. Okay, that's the graph that we want. Okay, this one's a little bit different. And so on the last one, we had 4 points that bounded it in. It was a 4-sided figure. Here we have 1, 2, 3, 4, 5 points that close it in. Sometimes it might be a triangle where it might only be 3 points. Okay, so that's the part that could change. It's not the same every time. Basically depends on where the lines are at and what type of figure they're going to form. But basically, we have a 5-sided figure. Okay, this is the p function. And like I said, that letter is going to change. Don't necessarily pay attention to what that letter means or represents. It's just a variable that they're using here. It doesn't necessarily represent anything. We're going to take, this time it's going to be 5 ordered pairs instead of 4. And so we got to find the 5 points that enclose it. I would say 3 of them are pretty easy. Okay, we still got 0, 0 in the bottom corner. We got 4, 0, 0, 4. We got 7, 0. Okay, now we got to find this point here, and we got to find this point here. Okay, and this is, I think, a little bit easier than the one we did just a second ago. We don't necessarily have to use a matrix for this, because here my y value is 4. So I'm going to take y equals 4 and plug it in here. So 8 times 4 is 32. I'm going to subtract 32 from 48. So that would give me 6x equals 16. And 16 divided by 6 would give us 8/3, or 2.6 repeating. I'm just going to leave it as a fraction, mainly because it's a repeating decimal. Okay, but probably the 8/3 would be better, and I'll show you why here in just a second. Okay, the last point is this one right here. And right here, my x value is 7, right? This is the line x equals 7. So I'm going to take 7, plug it in for x. 6 times 7 is 42. Subtract 42 from both sides. So now I have 8y equals 6. And 6 divided by 8 would be 3/4. Okay, so over 7 and up 3/4, which is just a little bit less than 1. So that point should make sense, right? 3/4 is slightly less than 1. So my fifth ordered pair is 7 and 3/4. Those are my 5 points. Okay, everybody kind of makes sense there? I wouldn't use a matrix for that. In fact, using a matrix like that probably would be confusing because of the inequalities that we're given. Okay, the other thing that's a little bit different on this one, and that's kind of why I picked this one out, it has this additional number here at the end. Okay, it doesn't just have an x and y in it. So when I plug in 0, I don't just get 0. I get 0 minus 0 plus 60, which is 60. It's just part of that equation. That's just the equation that they gave us. Okay? The 60 is just a random number that's thrown into that equation. But we still got to plug it in. 17 times 0 is 0, minus 3 times 4 plus 60. So that would basically be a negative 12 plus 60, which is 48. Okay, when I plug 0 in for y, 3 times 0 is 0, so 17 times 7 plus 60. If you do that math, I think you get 179. Okay, these last couple, here's why I would use the fraction. I can't put 2.6 repeating back into my calculator when I evaluate. So when I plug this one in, I would do 17 times 8/3, because I could put a fraction in, but a repeating decimal, I can't. Minus 3 times 4 plus 60. That gives me 93.3. And then the last one, 17 times 7 minus 3 times 3/4 plus 60. And that gives me that. Okay. So I'm going to look at my 5 values here. 48 is the minimum, and 179 is the highest, so that's my max. And that's what the question is asking. Find the maximum and minimum value of the function and the values of x and y which they occur. Okay, so this one occurs at 0, 4. This one occurs at 7, 0. So if it's asking for the ordered pair, then you could say, what ordered pair gets me that? Okay, the last one that we're going to do here, I only got 3 examples today. This is also from the homework. Or the set of problems. This is number 66. Okay, and this one is not quite as much fun because they don't just come right out and say, here's my equations, here's my maximum minimum function, here's everything you need to know. They give us a situation or a story. We have to write all of the equations and inequalities on our own and then use that to do everything we just did. Okay, so that's what makes this one a little bit more difficult is we don't have anything given to us other than the information. Okay, so we've got a story problem here. Golden Harvest Foods makes two different kinds of biscuits, jumbo and regular. So right there, and if you read the very last question, how many of each size of biscuit should we make in order to maximize profit, and what is the maximum profit? So here, this company, this breakfast place, this biscuit company is trying to figure out how many biscuits of each can I make to maximize my profit. A lot of businesses do this, that's the goal, right? What is the maximum number of things I can make that is going to make the most sense for our business? So in this case, and it doesn't really matter which one you do with which, I'm going to say X equals jumbo and Y equals regular. Okay, probably not going to give you a 3x4 for these. These are going to be two variables, two equations in most cases. Those are the two types of biscuits that we make. We can make up to 200 biscuits per day. So the first inequality, the two of those together, we're going to make up to 100, okay? Or 200. So we could make 100 of each, right? That would be everybody's most logical answer is let's just make 100 of each. So that's the same. But that may not maximize our profit. That may not give us the most money. We want to figure out which one makes us the most money. Okay, so there's a lot of different combinations. You could have 50 and 150, but 200 is the most that we could make. Each jumbo biscuit requires 2 ounces of flour. Each regular biscuit requires 1 ounce of flour. And we can use up to 300 ounces of flour each day. Those are our two main functions, kind of like the first one that we did. Okay, the other thing that it doesn't necessarily talk about here, but because this is a story problem, we can't make a negative number of biscuits, right? So common sense tells us that X and Y, the number of biscuits I could make 0 biscuits, so it could be equal to 0, but I can't have a negative number of biscuits. So 0 is the lowest number that we're going to deal with here. So once again, we're going to make a quadrant. First quadrant is all we need, okay? And that's going to be the case most of the time. There are a few times where that may not be the case. Once again, cover-up method is probably going to be the most likely method here. In this case, it's pretty easy. They're both 200. Over here, if I plug 0 in for X, then 300 divided by 1 is 300. If I put 0 in for Y, cover it up, 300 divided by 2 would be 150. Okay, I definitely don't want to go by ones here, right? This is not going to make a whole lot of sense. And so probably just looking at my numbers, the most likely thing to go up by here would be 50s, because everything is multiples of 50 in this case. If I didn't have the 150, I could even go up by hundreds. But because I have the 150, I'm going to go up by 50s. So I'm going to go 50, 100, 150, 200, 250, 300. And I don't really need 300 on both axes. Okay, we already know that we're confined to the first quadrant. That's what the x and y greater than or equals 0 will do. For the first graph, 200, 200, make our line. For the second graph, 0, 300. Just make sure that you put them on the right quadrant, in the right axis, okay? So 0, 300 goes up 300, 150 is on the x-axis. And then once again, we're going to look for the bounded in region. That would be this little region right here. All right, so we have 4 points that enclose this. Okay, those 4 points right there. Okay, the other thing that we have not done yet is it tells us the profit. There towards the end of the problem, it says the profit from each jumbo biscuit. So I'm going to say P equals, so P would represent our profit. We're going to make 80 cents on each jumbo biscuit. So 80 cents times X. And we're going to make 50 cents on each regular biscuit. Okay, so that's my profit function or my max min function. Here, we're not, very seldom in business would you minimize your profit, right? So here, the only thing we're looking for is our maximum profit. What's going to give us the most money made? What combination of biscuits? Okay, so we got to do our forward pairs. 0, 0. Well, if I don't make any biscuits, I don't make any money, right? That's what it's saying. So that's probably not going to maximize. So 0, 0 is definitely out. That would be your minimum probably here. We have 0, 200. We have 150, 0. And then we got to find this guy right here. Okay, and once again, don't try to look at your graph to determine what those points are going to be. We never really know what those points are going to be. So don't try to use your graph to determine that. That's where you would go to your matrix. And you would get, you would put in 1, 1, 200, and then 2, 1, 300. Kind of like the very first problem that we did. First equation, second equation, put it into the matrix. And it doesn't matter which one's on top and which one's on bottom. You could flip-flop those two, okay? So it doesn't matter which one you list first. But if we do RREF with that, it would be 100 of each, okay? And it may not always be that, okay? So don't just assume it'll be 100 and 100. We're going to make the same amount of each one. And then the final thing we got to figure out is which one of these maximizes my profit. Which one's going to make me the most amount of money each day? Well, this one here is 50 cents times 200, which is $100. Okay, here we're going to take 80 cents times 150. That'd be $120. And finally, if I do 100 of each, then that would be 80 cents times 100 plus 50 cents times 100 equals 80 plus 50, basically, which is $190. So this is my max profit just for the biscuits. Each day I can make up to $130. And in order to get to that, we would have to make 100 of each. That's the order pair that gets us there. questions on that? Kind of makes sense? And obviously the story problems are a little bit more work, mainly just because you got to get the equations in there. All right, assignment here. Okay, this should be the same pages as the other day. Sorry about the confusion on that. I'm only going to give you 2 problems here. Number 64 is one that doesn't have any story problem with it. And then 67 is the story problem. Okay, so one with the story problem, one without the story problem. Bless you. Anybody going to be gone tomorrow? Need to review early?